This is AP Calculus Self-Check 7.1 Solutions. Let's talk about our first problem. So for part A, it's asking if the speed is increasing, therefore we need to check the velocity and acceleration. So the velocity at 5.5, and we need the acceleration at 5.5. And so the velocity at 5.5, I got on my calculator negative 0.453.
Woo. How did you get that?
So I can open up this thing. File, open recent, TI-83 plus. So to do that on my calculator, I have to enter this equation. So I go to y equals, and then it's going to be 2 sine, and it's going to be second natural log to get to the e to the power of, and then it's going to be x divided by 4, then all of that plus 1. So to plug in for velocity, you basically do vars right, enter, enter. So I have my y1, and I do parenthesis 5.5 end parenthesis. It tells me when I plug in 5.5 into my velocity, I get negative 0.453. Negative 0.453.
Would it also work to just enter the equation and put 5.5 as t?
That would also work, yeah. So if you have your window correct from
That's what I did.
0 to 6, 0 to 6, and you graphed it. Oh, I should do. So if I go to zoom 0 to scale that correctly, you can just hit the trace button to get there as well. Waiting. So yeah, you can hit trace, and then you can do 5.5 on here, and then it will tell you the y value, negative 0.453.
Wait, didn't we?
All right, so the acceleration at 5.5, how did we get that? So the way that we can get acceleration is by taking the derivative. You can either just enter it into this equation if you want, that'll work. I think the quickest way of doing it is going to math. We're going to take the derivative. We're going to take the derivative of our y1.
You're so smart.
Wait, so math? What? I'm sorry.
It's going to be 8. Math 8 for derivative. And we're going to plug in 5.5. And when we do that, we get negative 1.359. Either way, we will get the same answer. If we plugged into this, I think this way is just a little bit faster. So this is going to be negative 1.359, rounding to that third decimal place. And notice that these are both the same sign. So same sign.
Same.
And that implies speed increasing. Speed increasing.
Okay, what if I got the right answer but the wrong way?
The wrong what?
Because I don't see it.
What did you do wrong?
So I thought it was speed and slope, so I went to 5.5 on the graph, and I was like, okay, they both go down, and they're below the x-axis. They're both like negatives, and it's the same, so it's increasing.
Yeah, that's the quickest way to do it too. Yeah. So if I get if I go to trace 5.5, you're really looking for slope and position, right?
Yeah.
So the slope is negative, the position is below, therefore speed is increasing. That is the
So I
fastest
did
way.
get it right.
That is, yeah, please do that.
So that's a way to check.
This is the way, you should probably just do it this way to go fastest through it. On the AP test, they just care if you do a negative here and a negative here. You can do that just by looking at your calculator.
My freaking parentheses, and I don't.
All right, so if you have, let's look at the way that you score this thing.
This one you're
So conclusion with reason. So as long as you say acceleration and velocity have the same sign, that's your reason. And speed increasing, that's also another point. So 2 points for A.
I mean, I still got negative.
All right, for B, find the average velocity. Average velocity, you guys remember how to do that?
not really.
Average velocity is your total displacement. So what is total displacement?
Oh, so that's when you go like. Oh, that's
From-
when you go math 8 or 7. Is it 7 or 8?
Oh, you're thinking about the calculator. Yeah, let me get this set up first. So you take the integral between 0 to 6 of velocity dt, and I divide my total displacement by 6 minus 0, by the interval, by the time interval. So it's total displacement divided by the total time interval.
Wait, can I ask you a question, Mr. Snow?
Go for it.
So if I got like on A, if I got a different like negative number, would it mean that I got it wrong?
No, they really just care if you got a negative and a negative, I
didn't
think.
write down the numbers.
I don't think you need to write down the number. I think you just need to have the conclusion that it's increasing, and it's because they both have the same sign. I'm not sure if they check this stuff. It doesn't look like it in my answer key. All right, so for part B, I need to calculate this. Are we all clear on where this came from for average velocity? This is in our notes also.
What is it over time integral?
Over the time interval, yeah.
What is it though over it? Sorry.
So what is on the top? On the top, this is the total displacement.
But I thought we were trying to find total displacement.
So for number B, we're trying to find average velocity. Average velocity is defined as total displacement divided by total time.
Okay.
I just plugged into the velocity or the acceleration equation, but that would be wrong.
That would be wrong, yeah, because that won't be average velocity.
Or the acceleration.
Is that the one?
Because you need to go to position here. You're going to acceleration. You're going the wrong direction.
No, like all I did was like I looked at the equation they gave me for acceleration and I plugged in for t and then that.
That probably will not get the right answer, but let's go ahead and go through it anyway. So I need to do the integral from 0 to 6, so I'm going to go to math 9. And that's going to be the integral, and I need to say integral of my y variable, so y1, with respect to x, and it's from 0 to 6, 0 to 6. And you should get 11.696.
So, wait, I got that for C.
So that's total distance, and that's not correct. Total distance is absolute value. All right, so coming back to part B, this is going to be 11.696 divided by 6, and when I do that on my calculator, divide by 6, that's going to be 1.949, and that is the answer. That is the average velocity.
Okay. So,
So the way to score this one is if you have this integral, you give yourself +1, and if you got the answer, give yourself another +1. So we're up to 4 points
Wait,
now.
so what's that? So average velocity is
Total displacement divided by total time.
so I ended up doing math 8, and I never divided by 6.
Yeah,
So that was like two major things.
I agree. You need to do the integral, not the derivative.
oh I get it because that the equation they give you is just for that moment, but you're looking for average.
Right.
Okay, that makes sense. So that's
What's
what
at the bottom of the equation?
This 6 minus 0,
Yeah.
that's going to be total time. Total displacement divided by total time. All right, on to part C. So part C is finding the total distance traveled. That's going to be the absolute value because we want to treat that negatives on our curve, this negative as a positive value. So the way that we do that is we say it's the integral between 0 and 6 of the absolute value of velocity. So velocity, absolute value dt. And that's all we really need to write here. And the way that we do that on our calculator is we get out of this, we say we need to do the integral, so math 9, the integral of, and it's not just y1, it's the absolute value of y1, so that's going to be math, and I go right, and I hit ABS, so I have absolute value. Absolute value of y1, so I'm going to go vars, right, enter, enter.
Wait, how'd you get abs?
Abs is math, right, enter. It's under number category.
I didn't hear that.
Wait, it was math 8 or math 9?
Math 8, or math 9 for integral, math 8 for derivative, so this one is a 9.
Are we ever gonna do math 8 or should I
Yes,
forget
we
it?
eventually will do math 8. I mean, we just did math 8 for part A. Part A for acceleration, we did math 8.
Bars, right, enter.
Enter, yeah. So that's going to be, oh, I don't want to end parentheses. So I do the absolute value of y1 with respect to x from 0 to 6. And it'll take a while to compute, so I'm going to leave that up here. Do we have
Wait,
questions?
so
In?
is this the one that's like start plus change and that's something totally different?
That's going to be part D. Yeah, it's going to be finding the position. Position is equal to start plus end, or start plus change. You can see that my calculator is still slowly calculating what that is, and it'll take a
So
while.
now how do I, if it gives me an error, I don't have to
Okay, go to. Hit 2.
Hit 2, yeah, go to see what it was.
You hit enter for it to
yeah.
calculate everything?
Yeah, and it will have that loading bar on the top right. So I got 12.573,
Let's see if we have
12.573, and that is the answer. So 12.573, how do you score this thing? If you did absolute value with the integral, give yourself a point. And if you got the answer, give yourself another point. You'll notice we are up to 1, 2, 3, 4, 5, 6, 7, I think. No, we're at 5. We're up to 6. Sorry, there are 6 of these. Can't count. And then finally, we go to part D. I'll get this out of the way for now. So part D. For this time interval, the particle changes direction exactly once. So I need to find that position at that time. So it changes direction. If I look at my graph, you can see that all of a sudden it changes direction at here, at this point. So the way that I do that is I need to calculate the 0. So I go to second trace and I hit 2. I'm calculating the 0, so I scroll to the left of the point. I hit enter. I scroll to the right of that 0. I hit enter. I have my guess, which is right about there. I hit enter, and it will tell me that it's 5.196.
Yay.
5.196, and that's for the time. So what I can do is I can set up a table that says time, and then this is going to be start plus end, or start plus change, and that will equal the end. So what is a position that we started at? It says x equals, at time 0, you're at position 2, so the start is 2. I need to add, what was the change? The change between 0 and 5, so that's really the integral from 0 to 5.196, 5.196 of velocity.
How is your start 2?
How's my,
Yeah.
It says right at the top.
Oh.
yeah, right there. Start is 2 in the x0 part of the problem. All right, so now I need to calculate that integral. So the way that I do that is I go to my graph and I do second calculation. I'm gonna hit 7 between 0, enter, and I can just do 5.196,
Wait, what did you click? You
5.196.
said second trace and then what?
Second trace and then 7. We're doing the integral.
Oh, and then 0 to 5.196.
Right.
Wait, what number do you press?
Second trace 7.
Perfect. So we got that that's going to be 12.135, and we have to add the 2. So don't forget to add the 2. And the way that we do that, well, yeah, we just add it and we get our final answer of 14.135. That should be the number that goes right here. I just ran out of room. And what is the question actually asking for? Find the position, and the position is 14.135. That is the position.
Oh, I get it, because if we just solve for the first thing of what's time, that's not position.
Right.
So then that's why we have to do
Yeah, so the way you score part D, you give yourself a point if you included the initial condition. If you put 2 down anywhere on here, give yourself +1. That's an easy point to get.
Which this is the one that's
Then
like
put 2
start
in.
plus change equals end.
Yes, because you're talking about position.
What if you only got the 5.196?
I don't think you get any points if you do 5.196. You get 0. If you set up the integral between 0 and 5.196, give yourself another 1 point, but you have to have the integral. And if you have the answer of 14.135, give yourself another 1 point. So this was all out of 9 points. This entire problem was out of 9.
I got 2 out of 9.
Yeah, I think I got 3 out of 9.
I think I got 3 out of 9 as well.
Please do score yourself. I want to know what scores we got.
It's just
It's just a lot of work. to do
Mr.
it.
Smith, I'm doing something wrong on my second trace.
All right, I'm going to conclude the video right here.